All right, guys, I think I'm recording this. So I just wanted to do the lesson that you need to watch for tomorrow. I'm doing this at school on B period. So hope that we can get all of this in my little lunchtime. We just have to do number 4 and number 5 and 6. 5 and 6 kind of go together. So number 4 is a lot like the two that we finished up with in class. These we had to solve or simplify. We set each part equal to 0, and then we asked ourselves, okay, what angle gives me an x of 0? What angle gives me a y of 1/2? Or what angle will have a tangent of 0? So those are kind of the questions we ask. These next 4, I think, are exactly the same. The only difference is I want my answer to be in radians, not in degrees, okay? So that's the only kind of thing I'm changing here. I'm going to scroll down to number 4. We're going to do 4, 5, and 6 on this video. That's what you're required to do. Make up on your notes. Let's move everything to one side. So on 4a, I want to minus that tangent from both sides. And I'm going to get tan of x times sine squared x minus tan x. The reason that's helpful is because now I'm going to factor tangent out of both of those. So I can take a tan out of this one and a tan out of this one. And that's going to equal sine squared x minus 1 equals 0. Okay. Now I have my two different parts, just like the few above. We're going to set each of those pieces equal to 0, and then we're going to solve. So I'm going to think about, okay, tangent of x equals 0 and sine squared x minus 1 equals 0. I think the tan of x equals 0 is an easier one, also because we just have already done this one. That's tangent is y over x. So I'm asking myself, okay, what angle is going to give me a y over x that's 0? In that case, my y must be equal to 0. And then I don't really care what my x is. It could be anything. 0 divided by anything is going to give me 0. So I'm looking for where my y's are 0. Since we've been practicing the unit circle, I know that this is going to be x equals y is 0 at 0 degrees or 0 radians, and it's 0 at 180. We said that earlier. But again, my answers are not in degrees, it's in radians this time. So the equivalent of 180 is pi. So my answers here so far are 0 and pi. Okay. We did that one above. I'm just literally giving the answers in radian form. Now we're going to look at this one. We have not done one that's a square, but that's okay. I'm just going to get sine squared by itself. And then I'm going to square root both sides in order to get my sine alone, not sine squared. I just want normal sine. When I square root both sides, I just get sine of x. And the square root of 1 is not just 1. It's going to be positive or negative 1. So I need you to be cognizant of the positive and the negative. So now we're asking ourselves, what has a sine, or in this case, a y of positive 1 or negative 1? Well, my answers there on my unit circle are going to be my other two quadrant angle. It's going to be 90 and 270. So that's pi over 2 and 3 pi over 2. So technically my answers for this problem is any one of my 4 quadrant angles. Okay. Again, the reason we had to do plus or minus is because I did the square root of 1. You do the square root of 1, it could be positive 1 squared or negative 1 squared. That gives you that 1. Okay. Let's go do the next 2. Okay. The next one says tan squared of x equals 3. Well, I'm not going to move the 3 over because I don't have any other trig functions. I actually can just solve this here. Just like we finished that last one off, I'm going to square root both sides. Square root this to just get tan by itself. And so now the problem I'm looking at is tan of x equals plus or minus root 3. Okay. And so I'm asking myself, okay, what angles are going to give me a tangent of plus or minus root 3? We just were doing tan a minute ago, and we remember tan is y over x. To me, whenever we get these root 3s, we've done a few of these, so I feel like you should kind of have this like in the top of your head. In order to take a fraction divided by a fraction and get root 3, that numerator needs to be root 3 over 2. That's the only one of my numbers on the unit circle that can be in order to get root 3 out. And that means that my denominator has to be 1/2. I'm in the middle of something. Your test is an extended time. It should be at least. Thank you. So what I'm going to do is I'm going to look for the points that is 1/2 and root 3 over 2. And so I'm thinking, and it can be positive or negative. So anywhere on the graph that has points 1/2 and root 3 over 2, those I remember are my 60-degree angles. And so those are my pi over 3 radians. The hard part about this is you just have to kind of know them, or you have to be familiar enough to remember what they are. So I've got pi over 3, I've got 2 pi over 3, 4 pi over 3, and 5 pi over 3. And I have to do all of them again, just like the last one, because I did my plus or minus, I have to give all of the options, and it's any 60-degree angle in any quadrant. Okay. I'm going to move on to number 3. Similar to the first one that we did, let's move the sign to the other side. Again, since I've got several trig functions here, I want to move everything to one side. I didn't on the last one because I only had one trig function, but I've got several this time. Sine x tan squared x minus sine x equals 0. And then I can factor sine out of everything. So sine x times tan squared x minus 1. And then just like we've been doing, set your pieces equal to 0. Sine of x equals 0, and then tan squared x minus 1 equals 0. Okay, so sine, I asked myself, okay, what angle has a sine? Or remember, I always think in terms of x and y. What has a y of 0? I think we've done this before, but my y's of 0 are at 0 and 180, or 0 and pi. Zero and pi. Come on, boxes. Okay, and then now I'm going to go over to the tangent one, move everything to one side, and then we'll do our square root. So let's add that one to both sides. We've done this on the, we've done this a couple times now, so I want you to square root both sides. The square root of 1 is still just 1, so I'm looking for a tangent of x that equals plus or minus 1. So again, my question in my head is, what angles give me a tangent or a y over x of positive or negative 1? Now, the only way to get this, and hopefully we've done enough of these that you already know which angle I'm talking about. The only way to get this is to have the same number in my x and my y. So my x and my y need to be the exact same number. The only x and y that are the exact same is root 2 over 2, root 2 over 2. So that means I'm looking at a 45-degree angle, or all my pi's over 4. And again, I want all of them because I'm doing the plus or minus of it. So x equals pi over 4. Let's make that a little smaller. 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay. Everybody doing okay? I know you can't answer me, but just checking in. Okay, I've got one more like this. This last one's a little bit tough. The only difference here is I have cosine squared and I have a normal cosine. We can't combine those. I want us to kind of imagine that this is, instead of written as 4 cosine squared x minus 4 cosine x plus 1, I want us to picture it as 4x squared minus 4x plus 1 equals 0. I want us to think of cosine squared x as just the variable x. So I'm replacing cosine squared x with just an x. The reason I'm doing this is the second way I wrote it looks way more like it makes sense. This is an actual factoring problem that you should be familiar with. Unlike the one above, I think I would have a little bit more trouble with that. So instead, I break it apart here to just be a normal factoring. And so now I ask myself, okay, let's factor this apart. It's a tough one because I gave you a coefficient in the front. So I've got to figure out, okay, what x plus or minus something, what x plus or minus something. I could choose 4 and 1. I'm probably going to do 2 and 2. And then numbers that multiplied be 1. Let's maybe try 1 and 1. That will be negative 2x. That'll be negative 2x. Negative 4x. Good, okay. I've got 2x times 2x is 4x squared, and then you do your inner outer, you get negative 4, multiply. Okay, perfect. Just doing my little factoring out loud because I haven't factored for a minute, but this is the factored form. Now that I'm in my factored form, I can replace those x's with my cosine squared x. Okay, so I'm going to go back and make this 2 cosine squared x minus 1 and 2 cosine squared x minus 1. Okay. These are the same factor, so I actually don't need to set them both equal to 0. I'm just going to pick one and do that one because it's going to give me the same answer. So I'm just going to pick this first one and I'm going to set that equal to 0. So 2 cosine squared x minus 1 equals 0. Again, just reminding, we did a little bit of substitution to substitute out that cosine x in order to put it in a variable into a factoring form that I know and can make sense of. I factored it, and then I substituted cosine x back in to finish my problem. And then now we're doing what we've done on all the other ones, setting my pieces equal to 0. Set your pieces equal to 0. Add 1 to both sides. I get 2 cosine squared x equals 1. Divide by 2 on both sides. Cosine x squared equals 1/2. Square root both sides. This now becomes cosine of x equals 1 over square root 2. Square root of 1 is just 1. I don't know what square root of 2 is. Luckily, we did a problem like this in class today, so I know to rationalize because now I can use a number that's on my unit circle. So I'm thinking essentially cosine of what angle equals root 2 over 2? Cosine of what angle? And since I did my square root, I probably should do plus or minus, shouldn't I? Wait, what am I doing? Give me a second. Give me a second. Team timeout. Oh no, I'm sorry I made a mistake, guys. I should have just replaced that x with cosine x. And so this should have just been cosine and just cosine, which actually makes this a lot easier. So I actually was done a second ago. I'm so sorry. I was rushing. Okay. Rewind. Restart. Cosine is what I replaced this as. That's why this became cosine squared. Right here. And that's why I replaced cosine x with just x. So this becomes negative 4x. Okay. I apologize. That was confusing, but we're good here now. I'm done at this step and I'm going to say, okay, cosine of what angle is 1/2? Cosine of what angle is 1/2? We know cosine is x. My x, that's 1/2 or 60 degrees. So it's at pi over 3. And the other positive cosines in quadrant 4. So that's 5 pi over 3. Okay. Okay, I'm sorry for that confusion. We'll talk about that in class next time, but I'll just kind of review it. But I did fix it. This is the correct answer. I just should have done cosine x the first time, not cosine squared. Okay, that's my answer. And that's my only answer because both of these factors are the same. 2 cosine x minus 1, 2 cosine x minus 1. So both answers would give me these pi over 3, 5 pi over 3. So I can just ignore the other one. Okay. All right. The last couple say use the calculator. So I'm going to get my calculator out. And it says to find all solutions of cosine x equals 0.37. This is not a unit circle problem. That's why we got to use our calculator. So what we're going to do is we're going to go to the calculator and we're going to do inverse cosine of 0.37. Okay. And I'm going to see what the calculator spits out for us. And then we need to use our brains to figure out, are those all my solutions, or do I need to do some manipulating in order to figure out what's going on? So let me go get my calculator. Okay. I'm going to make sure I'm in degrees. Okay, I am. So I'm going to do second cosine of 0.37. And I get 68.28 degrees. Doesn't say what to round to. I'm probably actually going to keep it a whole number. So I'm going to make it just 68 degrees. Okay. That's true. I'm going to argue there's at least one more cosine or one more angle that it works for, and then we're going to have to find the radians. Okay, so I just plugged in my calculator to spit it out. However, now is when we have to use our brains. Brain time. 68 degrees is somewhere in quadrant 1, right? 68 is probably like here. We know that it's cosine of this positive 0.37. So my question is, where else is cosine positive? I know all students take calculus. So that means I also have a positive 0.37 in the fourth quadrant. I also have it down here. We're going to use what we know about bow tie angles. So we went up 68 degrees. I can go down 68 degrees. So in order to find this other angle that also works, we're going to do 360 minus 68. And so another angle that works is going to be 292 degrees. I bet I can go backwards to prove this. Okay, so if I type in cosine of 68, I get 0.37, blah, blah, blah. If I type in cosine of 292, I also get the exact same answer. So that's how I know it works. If I did it in the third or second quadrant, it would give me a negative number, which I don't want. So that's why it's 297 or 292 and then 68. Now, if we want to find radians, it's super simple. We're just going to multiply by pi over 180. And I'm going to just do that in the calculator. So 68 times pi. 68 times pi. And then divided by 180. So that is 1.9 radians. And then we're going to do the same thing for 292. I'm going to multiply it by pi over 180. It's not going to be a pretty cute one because this is not one of our normal unit circles. So I get 5.1 radians. Okay. So kind of to review what we just did, we did the inverse cosine of the ratio given to us. So we did second cosine of 0.37. And then we used our knowledge to know which other quadrant it was in. And then we were able to find what its matching angle was, what angle goes with it. Then we multiplied by pi over 180 to get my radians. Okay, the last problem, we're going to do the exact same thing, but we're going to do tan of x equals 5. So to start, just like we did before, we're going to do inverse tangent of 5. And we're going to figure out what that equals. Second tan 5. Second. It's important it's second tan, not normal tan. Second tan of 5. And I get 78 point, let's round that up to 79. Okay. Again, all we've done is plugged and chugged in the calculator, so that's pretty self-explanatory. The second part we need to do, though, is use our brains. 78 is probably like here-ish. So we got to use our bow tie angles, and we got to remember our all students take calculus. Sine or tangent is positive in what other quadrant? Quadrant 3. So I basically have this same bow tie angle in quadrant 3. However, this time I'm not going to do minus from 360. We are essentially going to 180, and then we're going to go 178 from that. So I'm going to do 180 plus 78. That's going to be my new number. The one above, we did 360 minus 68. Now we're going to do 180 plus 78 to get me into the third quadrant. Okay, so 180 plus, oh, sorry, 79. Why did I keep saying 78? I'm sure someone's at home yelling at me. I'm so sorry. This is what I get for trying to work ahead at school. Okay, 180 plus 79. Okay, and I get 256. So X also equals 256. Okay. Last step, though, it does ask for radians, so I do need to multiply by 180 over, or sorry, pi over 180 in order to get what both of those are as radians. So 79 pi divided by 180 is 1.4. And then 256 times pi divided by 180 is going to be 4.5. Okay. All right. So that's it for your 5.1 notes. Your 5.1 homework is due the day after I see you for the test. So I believe that's Tuesday for Alpha and Wednesday for G. Wednesday for G is an e-learning day. So I don't know. We're going to figure that out later. I don't have the capacity for that right now. What I will probably do though, is attach a few more practice problems like the beginning of the lesson, like this stuff, this simplifying. We're going to use those skills in 5.2. So like we're going to continue to practice them. But if any of you want more practice, I have another worksheet or two. I'll put them in our e-learning folder. You don't have to do them, but I encourage you to if this is hard for you. You need to be all caught up on 5.1 the next time I see you after the test. Test is on Monday. Whatever I see you next, you have got to be caught up on this stuff. I think that's all for this. I'll write anything else in our little e-learning thing. If you have any questions, always email me, and have a good rest of your day.